Hello everyone, welcome to another video. Today I would like to demonstrate some of the new advanced signal processing features in glscopeclient. So we're going to be taking a look at a 1000 base X Ethernet interface, so 1.25 gigabits a second, 8x10 coded, acquired by this test fixture. At the moment we're looking at the unmodified signal straight into the scope, so let's get a better look at that. We've got the two differential legs, so we can subtract those. Do a clock recovery, threshold, and let's have a look at our decode. And unsurprisingly, it looks like valid 8x10b, but we're more interested in signal integrity right now. So let's take a look at the eye pattern. And as you can see, it looks pretty decent because this is a fairly short, high-quality cable, but I think we can squeeze just a little bit more opening out of this. So let's try de-embedding the cables. So we just say de-embed, specify, this is a mini-circuits FL08624. So now we can repeat for the other differential leg. And subtract these two. So now here's our de-embedded differential signal, and we can do a clock recovery on that as well. And let's see what the eye on this looks like. And we'll just give that a shorter name because the auto-generated one starts to get a little bit long. And we're going to use the recovered clock on the de-embedded signal. So if we then stick this on here, we can see that the de-embedded waveform does have a few slight changes. We've got a slightly faster rise time. There's just a little bit of overshoot. And again, not too surprising. These are short, high-quality cables. So let's try going the other direction. Let's see what this would look like if our signal wasn't so nice. So now let's see if we do channel emulation, and let's take a look at, we'll say if we've got one of my AKL-PT1 probes and we're going to use one of the less nice grounds on it. Let's say the Z ground, which is halfway decent, but it's not the highest performance one. So we're going to do emulation of that, and we actually don't need to be, we can do multiple S-parameter sets if we're trying to emulate a more complex channel and test fixture. We actually don't need to be emulating the cable because we're actually using that same cable to connect to our test fixture, so we're just going to emulate the probe body itself. And as you can see, it's quite a bit more rounded. This is a lower bandwidth. It's a 2 gigahertz probe, and then with the Z ground, the usable bandwidth is only about 1. So, unsurprisingly, it's a lot more rounded. And we're going to repeat doing channel emulation of the same thing with the Z ground on channel 3. And let's hide those as we get a little bit crowded. And we can subtract the emulated channel 2 and 3. There's our emulated differential signal. And clock recovery on that. Eye pattern. So, unsurprisingly, this is the worst of the three because we are simulating a far from ideal channel, but it's still totally readable. So, I hope this was useful and interesting. Thank you for watching. Until next time.